Okay, so correlation. The goal of many statistical studies is to determine whether or not there is a relationship between two variables. Well, sometimes there is a strong correlation between two variables, but when there is a correlation, it does not say anything about whether one cause the other one. So correlation is different from a causal relationship. So correlation is different from cause and effect. Okay, it's really really important. So, what is a positive correlation and what is a negative correlation? Well, there is a positive correlation when between two variables when there is an overall trend that as one variable increases the other one increases too. So if you increase one variable and the other one increases too, then there is a positive correlation. What is the negative correlation then? Well, if you increase one variable and the other variable decreases, then there is a negative correlation. So you increase one variable, the other variable tends to decrease. In that case, there is a negative correlation. But as we said, correlation does not suggest any causal relationship. It doesn't mean that one variable caused the other one. Not at all, okay? Cause and effect is different from correlation. So, based on this definition, the definition of positive and negative correlation, which graph shows a positive correlation between two variables? What do you think? Positive correlation, when you increase one variable, the other variable increases too. Okay, you're right. So that's A, right? A, this graph shows, a positive correlation. When you are increasing x, as you see, the value of y is increasing too. What do you think about these examples? Number of hours work in off-campus jobs and student success in classes. Is there a positive, negative correlation or there is no correlation? What do you think? Okay. Well, could be a positive correlation when the number of hours, oh, sorry, uh, when the number of hours that you work in on-campus jobs increases, right? Student success in class decreases. So could be a negative correlation. As you see, correlation does not suggest any cause and effect relationship. If you're working, in off-campus jobs, it doesn't mean that you're not going to be successful in classes. Not at all. So it's not cause and effect. But research studies suggest that there is a correlation between these two variables: number of hours working in off-campus jobs and a student's success in classes. Okay, as you see, correlation is different from a causal relationship. What about this example? Heights of students and student academic success at MRU? Positive, negative, or no correlation? Yeah, no correlation. No correlation. What about this one? Education level and median salary of Canadians. So, education level increases median salary. Okay, positive correlation. As I said, if you have a high level of education, it doesn't mean that it will cause, a higher salary. Not at all. It's different from cause and effect correlation. But research studies suggest a correlation between education level and the median salary of Canadians. Okay. So As we said, the correlation between education level and median salary of Canadians doesn't mean that education causes higher wages. Not at all. Doesn't mean that, okay? Correlation does not say anything about whether one caused the other one. Okay. Well, you can find the correlation coefficient, and based on the correlation coefficient we can find out whether or not two variables are correlated. Okay, here is the equation that we have two variables, one is x, the other one is y, and here is the equation that we have to find the correlation coefficient. So for the exam or any activity, well, you can use this equation. This equation, will be given to you, so you don't need to memorize that. So here it is. It explains what each term means, and is the number of data points, the number of set of x and y that we have. Okay, so sigma x, the sum of x values, sigma y, the sum of y values. Sigma x times y, it means multiply variable x by y and then add the products. Well, sigma x squared, it means that, find the squares of the x values and then add them all. Sigma y squared means, square the y values and then add the results. Sigma x means add all the x values, sigma x, and then to the power of 2 and then make it a square. And sigma y to the power of 2 means, find the sum of the y values and then square the result. Okay, here we go. Guys, my suggestion is that whenever you want to find the correlation coefficient, okay, create a table, okay, with these actually columns. One column for x, one column for y, okay, x and y are your variables. One column for x times y, one column for x squared, and one column for y squared. Always, always. That's my suggestion. Okay, whatever you have in each column, add the values. Okay, so that is the the number. These are the values that you need actually for the correlation coefficient equation. So create a table. Okay, add the numbers that you have in each column, and then when you add them, these are the numbers that you plug in into this equation. Okay, well, if there is a correlation, how can we find that it's a strong correlation or not? Well, the correlation coefficient actually has a value between -1 and +1. Okay, always, always. For example, if you use this equation and you find a value which is, for example, 2.5, okay, that means that you've done something wrong. The correlation coefficient is a value between -1 and +1. Okay, so when the correlation coefficient is 0, it means there is no correlation. If the value is 1, it means that's the strongest positive correlation that we have. And if we get -1, it means that it's the strongest negative correlation. Okay, so we always get a value between -1 and +1. Well, here we go. For example, when correlation coefficient is 1, we have perfect positive correlation. So here is how the variables are related. Part A. Look at part B. The correlation is strong. Okay, it's not perfect. It's 0.8. And as you see, part C is 0.3. The correlation is positive. It's like moderate to weak. And part D, that's when there is no correlation. Okay. Now E, F, and G, they show negative correlation. Okay. Part E is like moderate to weak. It's -0.3. Part F is -0.8. When you are increasing one variable, the other one decreases. So it's negative correlation and it's kind of strong. Yeah, it's -0.8. And part G, as you see, we have perfect negative correlation. Correlation is -1, as you see, right? Okay. Well, let's say in a 1971 study, involving 232 subjects, The researchers found a relationship between the subject's level of stress and how often they become ill. The correlation coefficient in this study was 0.32. Is it a strong relationship? Is it a strong correlation between the stress and illness? What do you think? Well, if we look at the graph, we can say that it's positive, right? It's a positive number, so there is a positive correlation, and it's just a moderate correlation. But, well, how can we judge, right? It's not easy. For example, if you have 0.4, do you want to say it's moderate to weak? So, how do you want to judge? Well, we're going to answer that question, don't worry, okay? So, we will use a table to judge whether or not the correlation, we can say there is a correlation, okay? So, well, how strong a correlation is, it depends on the number of, samples we have, and it depends on the subject too, right? The topic we are talking about. Well, let's see. Well, let's look at this example. Find the correlation coefficient for the data presented in the following table. Okay, what is it? They have selected, some countries. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They have selected 10 countries, and they wanted to see whether or not there is a correlation between the death rate due to accidents and the speed limit, miles per hour. And here are the results. If I use a graph, it's really hard to judge. So what I'm going to do, I'm going to use the correlation coefficient. I use the equation, right, to find out what the correlation is. So what I'm going to do, as I said, I'm going to create a table with these columns. One column for x, one for y, one for x times y, one for x squared, and the other one for y squared. So, for example, x is the speed limit and y is the death rate, okay? So, I choose one of them as x, the other one as y. Guys, don't forget, whatever you put the values in this actually table, you need to add all the values in each column. For example, these are the x values. I add them all, so that's sigma x. That is the number that you need in this equation. Okay, the sum of the values that you have in each column. So here is the y value. I add them all, right? So that's sigma y. This is the number that I need to plug in into the equation. So sigma x, sigma y. So x times y, okay? So for each row, look at the values. Multiply x by y and put it here. For example, for the first one, so 55 times 3. Okay, so 55 times 3, let me use my calculator, is 165. So 165. Next one, 55 times 3.3 is actually 55 times 3.3 is actually 181.5. Third one, 55 times 3.4, let's see what we get. 55 times 3.4 is 187, okay, and so on, okay. When you have x times y, you complete this column, you need to add all the values in this column. That's sigma x times y. This is the number that you use, actually, that you need to plug in into the equation, okay. Here we go. So I have completed the table here. I want you, actually, when you're at home, we finish this topic, I want you to calculate x times y. For x squared, for example, we have the value of x is 55. 55 squared is 3025, okay? Use your calculator. Well, y squared, whatever value you have for y, make the square. For example, first row, 3 squared is 9. When you have this table completed, add all the numbers that you have, right, in each column. Then you get sigma x, sigma y, sigma x times y, sigma x squared, and sigma y squared. These are the values that you need to plug into this equation, okay? So guys, be careful. N is the number of sets that we have, okay? That's like the number of rows. See, we have one set here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equal to 10. You cannot count x and y separately. We are talking about correlation between x and y. So 1x, 1y is one set. So you count the number of sets, okay? Okay, like x and y. Like that, you count like that. So n is equal to 10, right? Not 20, 10. And when you plug in the numbers, we get a correlation which is positive, and it's around 0.6, 0.59. I want you to do the calculations yourself and let me know if you do not get a number close to 0.59. Okay, here we go. Well, how strong it is, can we rely on the numbers that we get from this equation? Let's say we have a strong negative correlation between two variables, the value of negative 0.92. That's a correlation that we have calculated, okay? So R is negative 0.92. But we have a sample size of 10, which is not actually, big number, it's just 10. Can we truly conclude that there is a correlation between these two variables that we were talking about in this study? What can we do? Okay, there is a table in your textbook that can help us answer this question, okay? If we give you a question and ask you whether or not we can rely on this correlation, we will give you, of course, this table, okay? We have one column for n, right? For example, in this example, we are saying that n is 10, right? N is 10. And what was the correlation? Negative 0.92. And correlation is negative 0.92. Okay, forget about the negative, okay, for now. Sorry. And just let's look at the sample size and the magnitude of your correlation. Sample size 10. There we go. Guys, we have two columns. One is for alpha 0.05 and the other one for alpha 0.01. Okay? What I'm gonna do, for example, I focus on alpha 0.05, second column first, okay? And I compare the number given, okay, with the correlation that we have, the magnitude of correlation. Forget about the negative, okay? The magnitude of correlation that I have is 0.92. If this value is bigger than the value in the table, which is 0.632, then I can say that, yeah, there is a correlation, yeah? However, what does this alpha 0.05 means? Alpha is 0.05 means 5%. It means that when I say that there is a correlation, there is a 5% chance that I'm wrong. There is no correlation, okay? So nothing is certain. We just want to decrease the level of uncertainty that we have. So I say, okay, 0.92 is bigger than 0.632. So I can say that, yeah, there is a correlation, but there is a 5% chance that I'm wrong. When I say that there is a correlation, there is a 5% chance that there is no correlation. Well, similarly, if you look at the value for alpha 0.01, so alpha is 0.01. Well, the correlation number that I have, just don't, consider the negative one. Just look at the absolute value. As you see, it's bigger than the 0.765. So I can say that there is a correlation. But alpha is 0.01. It means that there is a 1% chance that I'm wrong. There is a 1% chance that when I say there is a correlation, there is not. Okay? So here is the meaning of alpha and this table. Here we go. So this alpha, 0.05 is like there is a 5% significance level, okay? So Here we go. We saw that the magnitude of correlation, the absolute value of correlation, is bigger than the data in the table, right? Here we go for n is equal to 10, right? Here we go. And I said there is a correlation, but there is a 5% chance, there is 0.05 probability that when I say that the variables are correlated, they're actually not related. They're not correlated, okay? And significance level of 1% when alpha is 0.01, it's like there is a 0.01 probability that when I say two variables are correlated, actually they are not correlated. Here we go. Well, when you plot one variable versus another one, you can actually fit a line. Well, guys, there are so many, softwares that they can actually find the best fit. Even you can use the Excel, you can use MATLAB, you can use Maple. Well, if you know coding, for example, you can use Python. Well, you can even use Excel, right, to find the best fit. But if you're willing to actually find the best fit and draw it yourself, these are the equations. But I suggest you to actually use the programs if you need to plot something. Okay, I don't want you to plot anything. Well, but just so you know, if you want to draw the best fit, you want to find the best fit, you can use this equation to find the regression line. Okay, here we go. So let's have a break. I stop here and then we will talk about the measures of dispersion. Thank you.